Okay, so it's really great to see all the passion about ecological restoration and our focus on more local resources, domestic resources, and solving these kinds of problems locally. My own passion extends into the cloud forest of Guatemala and cloud forests in general. Can you hear me okay? A little closer. So my own passion extends to cloud forests in general and especially in the neotropics. So I'm going to give you a brief overview of what a cloud forest is. Can you hear me any better?
No, I haven't turned this
Okay. So first I'll give you an idea of where they're found, and I'll give you some definitions, some working information about what they are. They're found in the tropics in very sort of narrowly defined areas. And they've sort of defied a technical definition, but in general, they're forests, broadleaf forests usually, sometimes conifers that occupy a relatively narrow elevational range. They cannot withstand freezing temperatures without a lot of damage. But they're in the condensation zone of warm air masses. So typically warm air masses are forced upward into the mountains. They cool and they release their moisture, but they also bathe the forest in fog. And cloud forests have the unique capability of combing vast quantities of liquid from the fog by way of the epiphytes that grow on them, which act as sponges. And so a lot of times you'll have a situation where the fog moves in, there's no rain, but the forest all of a sudden is dripping because it's saturated with fog. This fog creates very high levels of epiphytes, and these are areas that have much higher levels of vertebrate endemism than lowland rainforest. And they play a great role hydrologically because the water that these forests capture runs downstream, and a lot of it is also recycled. Cloud forests makes its own precipitation as well. I'll go into some of these in more detail. So 2% of forests are tropical montane cloud forests. And most of these forests have already been severely degraded or destroyed. There's a general lack of understanding or appreciation where these forests are and what they do. This is a global model of cloud forests that I did about 12 years ago, where you can see there really aren't very many places around the world where there are cloud forests. These forests in Africa have been largely deforested. There are still some, and these are the Atlantic rainforests of Brazil. You find a good smattering in Central America, as I've blown up part of Central America here. And then the Andes has a lot of cloud forest, as well as Indonesia and Borneo and New Guinea. So cloud forest is threatened by all kinds of land uses, legal and illegal, timber harvesting, and the fact that they're so little visited by, they're not areas where major cities have developed, so we don't know much about the resources. We don't know much about the biology of cloud forests in many areas. In some areas we do. Some of you may have been to Monteverde, Costa Rica, or at least heard of it. That's the best known cloud forest globally. This is the typical situation where you have fog rolling in and then the stripping of water from the clouds by the plants. You have a lot of situations, a lot of trees have much greater epiphyte mass than their own leaves. You can have hundreds of species of epiphytes living on a single tree. And then if you zoom way in, even on a dry day, you may find, on a day with no precipitation and in the sunshine, you take a look and you see, well, these moss are still dripping. It's quite remarkable. These are high biomass forests, or they can range up to approximately 150 to 200 metric tons of carbon above ground. That figure decreases as you go up in elevation, where if you reach the upper level of cloud forest, it ends at the paramo, which is an herbaceous vegetation type. This is a scene from Borneo where these, basically it looks kind of like a turkey foot or something, where these are canyons of lower elevation, and all the ridge tops are steeped in the clouds because that moisture is coming from the forest itself. Much of the moisture comes from the forest itself. And you can probably all think of times when you've seen mountaintops in the clouds. Well, these are perennially bathed in clouds in many areas. There is variability. There are different climates in different cloud forests, and they occur at different elevations in different parts of the world. And basically, this is a drawing of showing the stature of the forest as we increase in elevation and we increase in fog immersion. One of the almost unifying characteristics of many cloud forests are these arborescent tree ferns, arborescent ferns, which also have a global distribution. This photo was taken in Central America, where oaks tend to dominate the hardwood overstory. So I was considering cloud forest change with, in the context of global warming. And I devised a hypothetical mountain that is 3,000 meters tall and has 1,000 meters, a 1,000 meter range of cloud forest. And I wanted to know how much forest would be lost if we raised that, if that belt of cloud forest were raised by 500 meters under global warming scenarios. And I also want to know if that was realistic. So just doing a little math, I determined that if you raised the cloud forest band on a mountain of 45, on a cone-shaped mountain, 45 degree in slope, you'll lose 2/3 of the cloud forest itself, just in terms of aerial contraction. So how does that relate to the real world? There was a great study done along the Monteverde Bosque de los Niños transect, essentially, on resplendent quetzals in Costa Rica. And on the left here, you can see these elevational bands showing their occupation by the resplendent quetzal. And here you have the actual distribution and the density of the quetzal populations. And here you have a simulated 3 degrees centigrade warming of the vegetation and the habitat, showing what will happen to the quetzal as it loses habitat based on vegetation response to increasing temperatures. And what we found is actually greater than 2/3 contraction in the available habitat of the quetzal under this scenario at Monteverde. But this is a projection. So, so what does this have to do with the volcano? So, Morueta, Holm, et al. Revisited the Chimborazo volcano in Peru after 200 years after the vegetation was initially surveyed by Alexander von Humboldt in 1802 to look at the changes in the distribution of vegetation there. And there was a lot of detail provided in the original work, with all these different genera and groups mapped out, charted out on the mountain, different groups of vegetation. And what they found was a nearly 600-meter rise in the change of distribution, elevational distribution of the vegetation in Chimborazo volcano over 200 years. So we're seeing real changes. There was another study, I couldn't locate it last night for this PowerPoint, but it was a revisitation of Jared Diamond's surveys in the Solomon Island along elevational transects. And they also found very strong upward shifts since the 1960s, when Jared Diamond did all his bird survey work in the Solomon Islands. So both vegetation and bird populations are changing their elevation as global warming proceeds at this time. Another thing about tropical montane cloud forest, which I've abbreviated TMCF here, it's one of the habitats that is producing probably the most new species of vertebrates, new to science. And so this is a partial list that I made a long time ago of new species, most of which have been found in Peru. So if you get people who specialize in a certain geographical area, and they can really do the work. Lots of new species discovered. I think this list starts around the 1970s. And so the cloud forests are still producing new species to science. Unfortunately, as they're discovered, they're typically immediately listed as endangered, because the habitat patches they are discovered in are quite small, and they're being degraded by human activities. With this, I want to talk a little bit about the biogeography of Central America in terms of these montane birds. What I've shown here in yellow are 500-meter elevation contours, and these areas between them, which for some reason aren't showing up on the map with the lines, maybe here they are, they come up one at a time, are biogeographic barriers to dispersal of highland forest birds. And so we have a suite, an area rich with endemic species, some of which have been able to span larger distances. For example, this is a cloud forest bird, the white-faced quail dove. Doves are fantastic flyers, so they tend to be able to deal with the lowland areas quite well. The slate-colored solitaire, the solitaires are also widely distributed. Mountain trogons, a little less, so they're restricted to Honduras and westward. And the black robins are good flyers. And then we have certain species that are just endemic to the mountains of Chiapas and the highlands of Guatemala. They follow very, very distinctly the biogeography of the area. And one of the most enigmatic and important species in terms of my interest in this area is the horned guan, which is a monotypic subfamily with just one species. I might come back to that one. And so you have these species that have only evolved in central Mesoamerica. And I'll just keep on going. So the Nicaraguan divide is a region of low forest. And here we have the resplendent quetzal, which extends all the way down into western Panama. And as we move into Costa Rica and the Cordilleras, the Talamanca and the Tilarán, you just have a very high density of narrow endemic species which they occur nowhere else, and they're tied to mountains, and they cannot disperse to other areas. So when you view, and this little map right here is a compilation of all these different species occurring right there. And so when you place this incredible richness of endemic species in the context of global warming, we're talking about impacts to populations that are extremely limited spatially. Here we have a map of threatened bird species in Mesoamerica. This is a density map showing that basically most of the threatened species that occur in Mesoamerica are tied strictly to these montane systems. If you look at standing biomass, this from Sachi et al. 2011, we can see cloud forests in the Andes and this little bit right here as falling out in the 150 to 200 tons per hectare range, which is comparable to some of the densest, most carbon-rich forests in the world. These are very structurally complex. And so I went into my doctoral work with already having visited some cloud forests in Mesoamerica. And during the course of my work, I was inspecting satellite imagery and discovered this amazing spot here called Cerro Amay. And the reason why it was interesting to me was because there were no scientific papers published for this area. There was no bird literature, no anthropological literature, and yet it was intact forest. So I was modeling habitat for the horned guan and found this excellent quality habitat here in this location that had not received any attention. I didn't know if the horned guan would be found there or not, but in 2007 I decided to go down and look for myself. What I found was 19,000 hectares of virgin cloud forest surrounded by agricultural land uses, and I fell in love with the area. I was intrigued by the fact that nobody else seemed to know it existed, and yet here was a world-class resource that was occurring in a very, very poor Central American country. So I'll go through some of the photos that I've taken over the years. It's just a very brief introduction of this area. To give you an idea of what it looks like, what the forest floor looks like, it's perennially wet. The underlying bedrock is karstic and laced with caves. I'm not going to go into a lot of detail. We have plenty of endangered species, a critically endangered frog here, tiny frogs, very, very large beetles. This is a cloud forest group. The whole genus is, the whole family is cloud forest. Anybody know what this one is? Tailless whip scorpion, subterranean. And I'd love to know if anybody's ever seen anything like this. This is a tree covered in sphagnum moss. And it seems to be an extremely rare occurrence. This is a real color, natural color, sphagnum moss covered. The tree's still alive? The tree is alive, yes. It's an oak. And roots of some of the monocots, flowering structures of monocots, cross-section of tree ferns. Dense epiphytes, bromeliads, oddly colored ferns. Clean water, and lots of quetzals and birds. We have two species of monkeys, the howlers, the Guatemalan black howler, which is endangered, and then the Velarosis subspecies of the spider monkey, which is critically endangered. And here, a juvenile ornate hawk eagle. And here, the largest terrestrial snail in Central America. And a lovely blue, spotted blue, powder blue mushroom. Land crabs far from any water up in the mountains, oddly. Some poisonous snakes. Also discovered that this is a pretty great place to go. It's fun to go there and explore caves. And I estimate there are approximately 5,000 caves in this mountain. And of course, one of the great problems is that it's being deforested. And so I've been dealing with these kinds of issues over the last 8 years. We stopped one of the roads. They typically build roads with no design criteria, so they may just erode for years, decades, or maybe even centuries. Timber poaching is very common. And so I started, when I went there in 2008, I was so impressed. I started an organization to try to help save this. And since then, I've developed these 4 program areas: sustainable community development, land purchases, ecotourism, and biological research and exploration. So these are ongoing programs. With respect to community development, I'm trying to get people to invest in macadamia plantations, because macadamia is a very, very long-lived tree. It's a specialty crop, brings a good price to the farmers. It provides firewood and is extremely nutritious. And so I've been working with communities to establish macadamia plantations. We've started an ecotourism venture, bringing mostly Americans down into the cloud forest. They're caving and they're going up into trees and they're hiking. I've also worked with local communities in a basket making workshop. There are unique fibers in the cloud forest that are found nowhere else. As part of the biological research, I have a system of automatic trail cameras, and we're documenting the wildlife, including the brocket deer and the margay. And the overall goal now is to establish this area as a permanently protected area. And I've established conservation partners with Funda Eco, which is a fantastic Guatemalan organization, and with CONAP, the National Protected Areas Council in Guatemala. And we have a long-term plan, which will probably take us another 10 years, perhaps, to establish a national park with the support of the people, with the support of local communities, with the support of governing councils, as well as the Guatemalan Congress. Thanks very much.